China is boosting its efforts at preventing the spread of desert lands. Working with private companies, the work in Kubuchi Desert has become a flagship project of these efforts.
During the past 5 years, China has restored over 10 million hectares of land affected by desertification. The desert area used to increase by 10,000 square kilometers every year. Now it shrinks by 2,400 square kilometers annually.
Since 2016, China has used public-private partnerships in the fight against the desertification, with companies investing in tourism and agricultural projects and farmers getting subsidies. Decades ago, this was a desolate desert. Now it's a garden, a tourism attraction in the middle of the desert. Not only it turns the land green, but it also generates income for local people so that such projects could be sustainable and expanded to more areas. China is also working with the United Nations, and efforts to control desertification has extended across the nation's border.
I think in United Nations we believe this is a model that can be replicated, that can have multiplier effect, and it can be replicated everywhere in the world where we have the right kind of building blocks, what I hear.
Yet it is too early to declare victory. China has one of the world's largest desert areas. 1/4 of the nation's territory is affected by desertification. 95% of that is along the Belt and Road economic zone that the country strives to revive. It requires great efforts to turn desert into green land, yet it will require more to keep it this way. 宁红 CGTN Kubuchi Desert.
How can we fight desertification and prevent its spread? How can we alleviate its effects on our life, environment, and the economy? And how can we restore desertified lands? These are fundamental questions every one of us were asking throughout the course. We have seen that the problem is wicked and very complex, and its impacts is devastating everywhere. However, the solution might not be easy as we think. So let's begin. In today's lecture, we would finally approach the solutions to desertification. Can we make our Earth beautiful again? And can we solve the problem of desertification? So today we're gonna talk about two different concepts. We're gonna start with types and techniques to combat desertification, and then we're gonna start looking at one of the possible solutions, which is the biophysical solutions. And among of many solutions, we would be only focusing on soil and water conservation. Without further ado, let's start. Desertification is a complex problem because it has been driven from a complex interaction between causes and the effects. We have seen how the climatic changes interact with the human activities on the environment, the socio-economics, and also on our life. So all of these things at the end of the day led to desertification. But the question now, can we solve this complex problem with a silver bullet solution? I mean, with a simple single solution? The answer to that question is absolutely no. Why? Because we cannot solve this problem as we think. It's not as easy as we think. It requires a process to solve this complex problem. First of all, to solve this problem, we have to generate and develop a deep understanding about the problem. What are the causes to the problem? What are the effects? How the interactions? What are exactly the conditions there? I mean the environmental conditions, the socio-economic conditions, and other conditions. Even after understanding this situation, we have to keep in mind that these factors or these situations might vary between one place to another. Therefore, we have to develop a very deep understanding on the situation of that particular place. Even if we understood the situation, then we have to search for the solutions. And here we can use our experiences if we are expert in this field, Or maybe we can search for successful cases like other countries who have already spent times, did trials and error to solve desertification, and learn from them. We look at their solutions and then we bring it here. We have to evaluate these solutions and select the most suitable solutions for our condition. And after that, we have to adapt the condition, or we have to adapt the solution. Meaning that the solution has been developed for a certain country. Let's say it has been developed, for example, for combating desertification in China. Then we have to know that the conditions in China are different. Not only the environmental conditions, but even the socio-economic conditions. And therefore, we have to adapt this technology to the conditions that we have in the place where we are solving the problem. We have to modify the conditions, we have to modify the solution so it can suit our conditions. Next, once we implement that solution, now the hard work should come, because we have to see whether this solution is working or not, and therefore we have to monitor it for a long time. So we have to get feedback about it, we have to collect data, and we have to see whether our solution is really effective or not. And then if it is effective, that's a plus. If it is not effective, we have to learn what can we do and what should we modify, and therefore our solutions must be flexible and responsive to complex environmental and social and political changes. And one most important point to remember, that our solution should incorporate all stakeholders. We have to bring all the land users, the scientists, not only from soil science, it has to be from different disciplines. We have to have the scientists, environmentalists, the specialists on climate change, the engineers, and the soil scientists, and the biologists, the ecohydrologist, and so many, because the problem basically consists of all of these disciplines. And then once we involve them in the solution, we have to get a continuous feedback from them, especially the land users. They are the one who are living there, and they are the one who can really detect the changes or see whether there is an improvement or not. The applied solution also have to have a combination of integrated solutions. And you will see in the coming slides that it has to integrate different techniques, because again, this is a complex problem and it's generated from a complex causes and it has a complex effects, and therefore we have to have multiple solutions combined together, or multiple techniques combined together, in order to have a realistic solution. However, the best thing that we have to keep in mind, prevention is always better than cure. So the most effective solution to the problem is to prevent its occurrence. Since desertification involves the three sustainability pillars, involve the environment, and it has an impact on the socio-economic life and the political aspects, therefore our solutions must combine all of these aspects. So in general, there are two different approaches or two different solutions to desertification: the biophysical techniques and also the political and socio-economic techniques. And remember, we have to combine all of these techniques. So now let's start with starting with the biophysical solutions. Now, the biophysical solutions are basically solutions that are intended to prevent the occurrence of desertification, or slow down the progression of the problem, or if the problem is already happening and already reached an advanced stage, then these techniques can help us to restore the degraded or the desertified lands. So the biophysical solutions are basically things that you do in the field in order to improve the situation. And this basically consists of soil and water conservation techniques, grazing management, salinization, erosion reduction, wildfire control, and water conservation or water harvesting. And because we know that most of the affected areas by desertifications are the dry land zones, because the situation there makes them very variable. In these areas you don't have so much rainfall, and small changes either in the climate or induced by the human activities can lead to serious desertification problem. And therefore soil and water conservation can work very well. So this technique, the soil and water conservation, are basically meant to conserve and save soil and water. Among one of the many techniques is the agronomic measure. Now, what is exactly the agronomic measure? The agronomic measures are something that you do for the agriculture. For example, you have conservation agriculture or no-till, or for example like manuring or composting or mixed cropping or contour cultivation and mulching. Now, all of these techniques that you do will eventually lead to improve the stability of the soil, the nutrient of the soil, would make the soil lively again, and also would prevent the soil and the water against erosion and many other causes of desertification. Now, if we look at the fundamental characteristics and objective of these agronomic measures, that they are usually associated with annual crops. That means you would continually do these measures, because look at composting, for example. You would be adding compost or fertilizer, so let's say organic manure, to the soil in a seasonal basis or in a yearly basis. So that's what you do. And for example, mixed cropping. If we look at mixed cropping, where you have different types of crops, you have perennial crops like the date palm, those crops who last for long years, or to stay long years or live to a long years. And then in between those crops, you also cultivating seasonal crops, and variety of seasonal crops like you see here. You have some vegetable, you have grass, you have flowers, all of these in the field. So you maximize the use of the field, and you also optimize the use of nutrient and fertility of that soil, because now you are not intensively degrading the soil by having one type of crop that will suck a particular nutrient. No, you having different combination of crops, and each one of them is using nutrient differently, so you would have a better management of the nutrient in the soil. Look, for example, at the contour cultivation. The contour cultivation, if you have, for example, if you have grass, okay, in your field, then you would do this every time that you're cutting the grass. Or the mulching, for example, so you would prevent the evaporation and so on. And you can do it by a plastic mulch, or you put, for example, some plant material, and you would keep doing this every time. That's why they are usually associated with annual crops, and they are repeatedly or routinely doable. And they are actually for a shorter duration and not permanent, because you keep doing them every time, because once you harvest, then you have to do it again and again and again. And therefore they are not zoned, and they will not change the topography of the land. So these are things that you apply, but you will not change the slope, for example, or you will not change eventually the topography of the land. Now, the second technique is the vegetative measure. Now, if we look at that vegetative measure, now the vegetative measure is basically you are trying to structure the vegetation or grow specific type of vegetation, and therefore it can preserve the soil and water. For example, it can lead to lower evaporation, evapotranspiration losses, or basically, and the most important thing, it leads to stabilize the soil against different type of erosion, like the water erosion or the wind erosion. An example of the vegetative measure is the grass strip, like you see in the picture, or the hedge barrier. And the hedge barrier is basically practiced in many places, so it can break the winds. And we have the windbreakers. Now, the windbreakers basically are meant and focused on reducing the effect of wind and the effect of wind erosion. So basically, you grow taller trees around your field, and as you can see in the picture, that when the wind is coming, it leads to slow down the vertical or slow down the horizontal movement of the wind acting on the earth, and therefore eroding the soil. So these are some of the things. Now, if you look at them, and if you take an example of the windbreaks, then these are perennial things like trees. So they are staying for a long time, because you won't grow grass as a windbreak. You need something tall that could break the winds, and something also strong, so it cannot be broken by the wind easily. So that should be perennial. That should be a tree that lasts for a longer time. Or you can do it with a perennial grass, like what you are doing with the hedging. You need something that would stay for a long time, let's say for 7 or 8 years. You just keep taking care of it, but it stays there, and they are for a longer duration, like what you see here. So, and in some time they might lead to changes in the slope profile, like the grass strip, for example, and they are aligned against the wind, like what you see here, and they are spacing according to the slope. Now, the third technique is structural measures. Now, what is the difference between structural measures and the previous two techniques? Now, the structural measures are things that you do. You structure the soil, or you restructure your land, and therefore you would change the topography of the land in order to make the soil and water more conservation, or in order to increase the conservation of soil and water. Let's say you are dealing with a slopey place, like the condition in Al-Jabal Akhdar or many other hill slope places. Now, you know that with the slope, once rain happens and the water start flowing over the surface, it would even increase the erosion losses, and that would be really devastating and can lead to degrade the land, leach the nutrients, massive loss of soil, and many other things. So in order to reduce the effect of these losses and to prevent the degradation, you would need to restructure the land, and you can do this by having terraces, for example, or banks or bunds and constructions. And let me give you more explanation. So the terraces, like the picture you see here above, and this is practiced a lot, and it's a very ancient technique, but it is really working for the problem. Stone bunds is another technique. So what you do here, you have your slope and you align the stones, so these stones then can slow down the water movement, and therefore it can therefore reduce the water erosion and stabilize the soil. So like this, and you would see that, as I said, it's lead to change in the slope, and they are basically meant for a longer duration. And let's see the example of Al-Jabal Akhdar. It's lasting for thousands and thousands of years, and they're still there. So that's why they're meant for long term. And basically, by doing them, you would be able to reduce the runoff and therefore reduce the erosion. But the thing that when you do these structural changes, you would need manpower, and therefore you would need to spend money to do this, because it's really a massive changes on the land. It's a laborious work. And again, they are aligned against the wind and spaced according to the slope, and yeah, like you see here. Now, the first technique is the management structures. Now, the management structures are now meant to deal with the human behaviors, because we are the one who are leading the problem. So for example, assume that you have a degraded area, okay? Let's say a degraded area because of, or a desertified area because of overgrazing. Now, one of the very simple techniques that you have to control or manage the grazing pattern on that area in order to reduce the problem or even to restore the problem. Let's assume now that that particular area is now degraded so much. So one of the things that you can do as a management is to prevent the use of that land. So you keep it as a natural habitat, or you keep it for a long time so then the ecosystem can recover itself. And this also can be applied for forest. When you have a desertification due to, for example, afforestation, cutting forest, or due to fires in the forest, or due to any other things. So what you can do, you can revegetate that area, or maybe you can just keep it and the ecosystem can recover itself. Another example of the management is to have rotational grazing. You know that grazing happens and overgrazing happens when it exceeds the carrying capacity of that land. If you have so much animals grazing for a longer time on that particular area continuously, then the rate of grazing, the animal eating the grass, would be faster and much higher than the rate of grass recovery. And for that reason, you must manage this effect. You must manage this activity. And you can do this easily by having the rotational grazing. So let's say that as actually practiced by the old time nomads. So you have different areas to graze, and you start, for example, for a few weeks in this area, then you move to another area and you let that particular area to recover, the grass to recover and grow. And therefore, by having these techniques, you might have changes in the land use, and that's the big objective of this one. And then you might not need to have agronomic or structural measures, because you are dealing now with the management. You are dealing with the land use. And of course, by doing this, you would lead to improve the vegetation cover, and therefore you protect the land against the factors that can lead to desertification, and you control the intensity of the use of that particular land. Now, something that I want you to keep in mind, that we have seen 4 different techniques. But remember, we cannot solve the problem with a single solution. And therefore, the most effective solution is to have a combination of all of these factors, all of these measures. And that would be really, really like an effective solution. So now let's take an example that you have a slopey land, okay, and you want to prevent desertification from occurrence, or you want to restore that particular area. So what you can do a combination of all of these things. You can have a structure by which you make terraces, and then in that terraces you would grow different types of crops, and you would have a mixed cropping, for example. You see now? And then also with that you would have mulching, for example. And you would put, for example, a fence, so you protect the area from the animals that comes to graze there, or even that when the animals walk over it, they can cause also a collapse. So you would do a combination of all of these factors, and this would be even more effective techniques. So this is to keep in mind that combination would be most effective techniques than having a single measure. So that's all for this lecture. I hope you enjoyed it. So you can read the book, this from chapter 7, and I would also advise you to watch these videos. So I hope that you enjoyed it, and thank you. Take care. Bye.